Now this page is particularly important because, as well as showing you how to work with orders of operation, I'm also going to show you how to set out your working so that can be easily followed and marked. And that's very important because if your work cannot be followed by your person who's marking your assignment, you can lose marks quite easily. So we've got something here that is quite a large number of operations within it. We've got addition here, we've got a bracket, subtraction, multiplication, not multiplication, addition and division. So what do we do first? Well, first of all, we have to evaluate what's inside the bracket. Okay, so that's what I'm going to write down first. But I'm going to keep all of the problem together. So I'm not evaluating 3 squared over 9 yet, but I've still written it down. Now inside the bracket, let's work out the bracket. Inside the bracket we've got 15 minus 7 plus 2. Now remember what I said, you need to work additions and subtractions in the order they occur. So it's read as 15, take away 7 is 8, add 2 is 10. So the answer for the operations inside the bracket is 10. And then divide by 2. Now notice the only thing I've done on this second line of working is evaluate the bracket. Also notice that this line of working is equal exactly to this line of working, as it should be, because that's what an equal sign means. It means this line is equal exactly to this line. So now we've evaluated the bracket, so the next thing we need to evaluate is the exponent, and we've got 3 squared. So 3 squared is 9. That's all I'm going to evaluate on this line. Write the rest of it down as well. Okay, so we've evaluated the exponent. Then we evaluate any division or multiplication. And you can see you've got a couple of divisions here. You've got 9 divided by 9, which is 1. And then we've got to add 10 divided by 2, which is 5. And now we can perform exactly the last operation, which is 6. Now that's the working to evaluate that very difficult looking expression there to get the final answer of 6. And that's the expectation when you work through these similar problems on your assignments. Let's have a look at the next one. Well, it looks quite difficult. What have we got? We've got a bracket, and then we've got some powers and a square root sign. Notice the square root sign goes over the entire expression. 5 squared subtract 4 squared, and that means there's really an implied bracket here as well around those two. You've actually got to evaluate 5 squared take away 4 squared before you can find the square root. So let's begin and evaluate the bracket first. We've got 3, and inside the bracket, and by the way, having 3 and then no operation and then a bracket means 3 multiplied by what's inside the bracket. So inside the bracket we've got 1 plus 6 times 2. Now we need to perform multiplications before we can perform an addition. So 6 times 2 is 12, plus 1 is 13. So we've got 3 times 13, subtract, and then we've got the square root sign, and we can evaluate what's inside the bracket under the square root sign. 5 squared is 25, 4 squared is 16. Underneath, in the denominator, 1 plus 8 minus 3. Okay. The first line there, the problem we were given, is exactly equal to our second line of working. What happens next? Well, we really need to get rid of the square root sign because we had to evaluate any, but we need to therefore first off perform the operation inside the square root sign there. So let's rewrite this as 3 times 13, we're not doing anything with that, and find the square root of 25, take away 16 is 9, all over 1 plus 8 minus 3. Okay, so 3 times 13 is the next line. The square root of 9 is 3. Almost getting there. Now we have a multiplication on the top line. 3 times 13 is 39 minus 3. Let's evaluate the denominator now. 1 plus 8 is 9. Subtract 3 is 6. Now we can, and by the way, I need to say to you that if we've got a divide sign, as we have here, or a divide line, and an expression above it, we need to evaluate that expression before we can divide. So hence there are implied brackets around 39 take away 3. So that means we have to evaluate 39 take away 3 before we can divide by 6. So 39 take away 3 is 36 divided by 6, and we have an answer of 6 again. Notice all the working. Each line of working is equal exactly to the line above, and each line of working I've really only performed one operation on it, but I can follow it right through to the very end, and if you do your working in this way, it's quite easy to pick up where you make mistakes. Okay, let's now move on to our next little problem, which is an example of estimating an answer to what looks like quite a difficult little operation. Now the point of this one is that we've got more than one operation here in this expression, and even though we're estimating, we need to take account of order of operations. Okay, so now let's round off. And the other thing we need to think about with this one is that we don't always round off to the nearest 100 or the nearest 10 for any particular number. It depends on what the number is. So for instance, for the number 36.75, I'd round that one off to the nearest 10. So so that will be 40. Now I've got a couple of choices with 5.8. I can actually round it off to the nearest 5, so that's either 5 or 10, or to the nearest whole number. I'd probably round that one off to the nearest whole number. So round it off to 6. 575. Now remember, I need to perform this operation once I've written it mentally. So I'd round that off to the nearest 100. and round off 8.5 to the nearest 10. So I haven't rounded off to the same place values, but that doesn't matter. I can still now do this in my head. 40 times 6, remember order of operations, so perform any multiplications or divisions before you perform the addition. 40 times 6, 4 times 6 is 24, add a 0, so 240, plus 600 divide by 10. Well, it's an easy way to divide by tens. That 10 divides into that 10, and we've got 60. So 240 plus 60, the answer is 300. Okay, I didn't need to write anything down. I didn't need to use a calculator. I could do that one in my head. And that's the point of estimating an answer. Round off so that you can perform the operations in your head. It's not the exact answer, it's an estimate of the answer.